The elements that go into building a technologically advanced, quality product begin with dedicated people and include thorough research and development, product testing, customer service, and marketing. At the Products Division of Cincinnati Milacron, the elements of quality are the elements of Cimcool. Cincinnati Milacron has been the leader in developing quality metalworking fluid technology since beginning research on the first synthetic metalworking fluid over half a century ago. The original Cimcool can trace its origins back to World War II. Cincinnati Milacron was then known as the Cincinnati Milling Machine Company. Under the wartime demands of high production machining and grinding, the inconveniences of casual times became major problems. At that time, most manufacturers used straight oil or soluble oil-type fluids to reduce heat and friction. Oil products, however, brought the risk of smoke, fire, slippery floors, rancidity, and unpleasant, dirty working conditions. The second problem was heat, which physically hindered the efficiency of high production. Everyone knew that heat was generated during machining and grinding. The oil products of the past were limited in their ability to control heat. A little too much speed, a little too much power, and the cutting tool was ruined. The demand for a new cutting fluid was there. So Cincinnati's researchers began to look for the causes of heat and how to diminish its generation. Their studies focused on one tool point making one chip, the unit of action common to all machining and grinding. Their first discovery was that a tool removes metal much like a snowplow lifts and pushes. This deformation produces 75% of the heat that wears out tools. The generation of heat was found to be a function of the thickness of the chip. If the chip could be made thinner by half while maintaining the same thickness of bite, the heat generating area should also diminish. Watch how this chip is made thinner, not by changing the thickness of the bite, but by swiveling this line. It marks the plane along which the metal is being deformed or sheared and makes a clearly defined angle with the surface being machined. This is known as shear angle. Reducing friction at the chip-tool interface increases the shear angle, which thins out the chip and reduces heat. Under a microscope, the chip flowing up the face of the tool appears rough. Its tiny projections collide with the equally rough peaks on the tool face. Depending on the horsepower at work, pressure at any one of these tiny contact points can build to 200,000 pounds per square inch or more. This is friction. This is what has to be reduced, and because of the terrific pressures, no fluid film, oils, or water will get between those points and stay there. As a result, these tiny points of contact tend to weld, and they must be constantly sheared away. More than a quarter of a horsepower is used to break them, and when those bonds are sheared, tiny fragments of the tool face are torn out and accompany the chip. The face of the tool becomes dished. Tools wear out. When enough of these bonded contacts occur in the same area, fail to shear, and chip material piles up on the tool face to become what machinists know as build-up edge. Hundreds of times each second they pass under the tool point and remain with the workpiece. This is almost the sole cause of poor finish. So 3 machining problems can be linked to inadequate cutting fluids. The bonding of metal to metal wears out the tool face. Friction keeps the shear angle low, causing more deformation. And particles of build-up edge escape with the workpiece and spoil the finish. But watch what happens when a small amount of fluid is introduced. The shear angle rises. The chip immediately becomes thinner. The power requirement drops, and much less heat is being generated. The build-up edge that causes poor finish is gone. Finish improves. In 1948, after years of research and development, Cincinnati Milacron introduced the first synthetic cutting fluid that would reduce and dissipate heat, lubricate the chip tool interface, flush chips, and in the process, prolong the life of the tool. This fluid carried a group of lubricants that actually harnessed heat and pressure to create a chemical reaction. The lubricants formed a solid in the tiny spaces between the chip and tool. The chip and tool formed bonds with this chemical solid rather than with each other. Now, instead of having to shear welded metal, the tool needed only to shear a weak chemical compound. The chip slides freely up the tool face. The resistive force of friction is clearly diminished. The shear angle is large. The chip is thin. Less heat is generated, and the tools last longer. Speeds and feeds can be stepped up, and more work can be done with each cutting tool and grinding wheel. Reducing heat solved only half of the original problem. Chemists and biochemists continued to search for the right combination of ingredients that would allow Cimcool to do its work without degrading the in-plant environment. The ideal fluid must not injure hands, stain clothes, or create dirty, depressing in-plant conditions. It must not develop a bad stench. It wasn't allowed to smoke or cause rust on workpieces or machines. And it must be a stable liquid that is easy to mix. Our Cimcool researchers found ways to effectively control bacteria. The odor disappeared, and with it, the principal need for cleaning and recharging machines. And in continuing toxicity and dermatology studies by independent laboratories, Cimcool products are proven to be mild in the workplace. Although Cimcool is a water-based fluid, it affords excellent rust control, protecting machines and giving valuable in-process protection to parts. Water-based Cimcool reduces carry-off with chips or the workpiece, providing a clean place to work. Approximately 15 years after the development of the first Cimcool fluid, environmental protection became a major concern in Europe and later in the United States and all other industrialized nations. Cimcool had been fighting some of the problems with pollution all along. Cimcool cleaned up in-plant contamination by providing clean, safe cutting fluids. Cimcool lasted longer than soluble oil products, had to be dumped less often, and therefore polluted less, simply because there was less to be disposed of. In the early 60s, pollution control methods were implemented. Possible pollutants in our products were identified, and several safe methods for disposal were developed. Today, the Products Division employs environmental chemists who research safe, effective methods of disposing of used Cimcool metalworking fluids. The environmental chemists also serve as consultants to customers and assist government agencies on a variety of topics. A complete line of Cimcool metalworking fluid equipment, including wastewater and fluid recycling equipment, is available to assist customers in wastewater management. Assistance and advice about wastewater treatment is just another element of the Products Division's commitment to quality and service. From a single synthetic cutting fluid, Cimcool products have grown into a complete line of metalworking and forming fluids and services designed for a wide range of metalworking applications. The main element in the growth of the Cimcool product line has been research and development. Today, scientists outnumber the production staff. In the multidisciplinary state-of-the-art Cimcool laboratories, new products and processes are developed, and existing lines refined continually. Cimcool has grown into a complete line of technologically advanced products and services introduced to meet the demanding needs of many types of industries and processes. Cimcool's machining and grinding fluid product line consists of water-dispersible synthetic, semi-synthetic, and premium soluble oil products designed to meet or exceed the requirements of the customer's application and working environment. Benefits include excellent corrosion control, high degree of lubricity for prolonged tool life, pleasant to use, greater stability in hard water, lower misting properties, the ability to be recycled, and easy disposal. The Products Division is also forging into a new area of expertise with Cimcool stamping and drawing fluids. A complete line of water-soluble products has been developed for a variety of metal-forming applications, including drawing and ironing fluids for two-piece beverage kegs. To maintain quality in all areas of a customer's plant, a variety of specialty products has been developed for other metalworking applications. Our industrial cleaners, tapping compounds, corrosion preventatives, and waterproof grease complement Cimcool metalworking fluids to keep customers' operations running smoothly and efficiently. Remaining the quality leader requires constant research and new product development. The Products Division has expanded the Cimcool line to include specialized products for unique applications, such as highly specialized aluminum machining and grinding, lens grinding, computer disc polishing, and silicon wafer slicing. As a division of a major worldwide machine tool manufacturing company, the Products Division has a unique competitive development advantage. Cimcool product performance may be simultaneously tested in actual manufacturing situations and in rigorous laboratory simulations. Cimcool products are designed for the highly technical and tough industrial applications, but the health and safety of the user are as important as product performance. Extensive microbiological, dermatological, and toxicological research assures that products under development meet current safety standards. To assure the consistent quality of every product that leaves the loading dock, the Products Division has applied statistical process control techniques to the processes used in manufacturing Cimcool products. In implementing SPC, there is an increased emphasis on prevention, with quality problems being eliminated before they develop. Quality doesn't stop with a good product. Superior customer service and equipment are needed to keep the products performing. The Products Division offers a line of metalworking fluid maintenance equipment that assists customers in maximizing the life and performance of their fluid. Quality also means providing customers with needed services. With Cimcool products, customers can depend on technical service and support beyond the sale, so they can concentrate on their manufacturing goals. Technical support specialists, environmental chemists, and other support personnel are available to help customers manage all phases of their fluid to assure the achievement of maximum results with Cimcool products. Services include testing customer samples in laboratories, training plant personnel in fluid control, and on-site evaluation and testing. A nationwide network of regional offices allows technical specialists to maintain close contact with Cimcool product customers. Each regional office contains a laboratory facility and fluid technical services specialists to handle testing and questions in the field. The regional centers are supported by the Products Division headquarters in Cincinnati, one of the finest equipped and staffed metalworking fluid research and service-oriented laboratories in the industry. The high quality of Cimcool is known all around the world. Manufactured in the United States and overseas, Cimcool products are distributed worldwide through local sales offices and authorized sales agents. By manufacturing Cimcool products outside of the U.S., we are able to have products and services readily available to meet customers' needs in foreign markets. The technological exchange that takes place between Cimcool laboratories at home and abroad means the most modern, up-to-date research and technology available goes into making every Cimcool product. The elements of quality have been the driving force behind the expansion of the Cimcool product line. The Products Division has developed a policy of absolute quality that has been incorporated into a complete line of products and services distributed worldwide. The pioneering spirit that began over half a century ago with the development of the first Cimcool metalworking fluid continues in today's research techniques to assure every new Cimcool product embraces the elements of quality.